Going to be a controversial video, mostly because people have a similar feeling about math as they do about writing. A lot of people struggle with math the same way people struggle with writing, and they struggle to feel like they do it well. There's often so the same thing when it comes to PTS for writing. I've seen similar things with math. I mentioned in the other video that that I'm one of those writing guys who, despite having a PhD in writing, rhetorics, and literacies, I came into college doing engineering, and then I shifted to theater production and performance, where I did a lot of lighting design and construction and carpentry for set design and that sort of thing. And so math is not something that's been a challenge for me. I came into college actually with calculus done because I had a really nice APIB high school program in 2003. So that was cool. That being said, I think the reason math and writing both work for me is because I see math as a language. And so it's the same principles we talked about with writing systems become really helpful if we can understand how they function with mathematics as a language. So I'm going to do a little bit of show and tell before I get into the content. So math is obviously something that a lot of people are used to dealing with in the sciences. You know, in the first couple sections of the physics textbook I have, we jump right into all these fun geometry things and force diagrams and all that. There's all these different symbol systems. Even when I was first getting into engineering, the first thing we did with engineering was we had to do technical drawing classes. And so we first learned how to rewrite the alphabet and rewrite numbers in special ways. But we also had to figure out how to deal with angles, how to use mathematical writing technologies. All these sorts of things still applied. But there's a reason why I'm showing you this. I also decided to pull out one of the interesting things with my calculus textbook from way back. The first major part of any math textbook is not just a list of problems. It is trying to help you identify what the pieces are. You'll see tons of definitions in math textbooks. That's because they're trying to teach you a language. They're trying to not just show you not just get you to practice mathematical stuff, but you have to know what language to use so you know what you're talking about, so that you know the difference between a limit, an integral, a sum function or sequence, those sorts of things. And so there's all this specialized language in calculus, in math, in algebra, and it's developed over time. There are plenty of other places where we learn about rhetorical context and writing in the disciplines and writing across the curriculum, where we're told that each discipline has its own unique language. Well, math takes this beyond that. There's specialized language in chemistry, and yes, there are a lot of root words that come from Latin and Greek and that sort of thing. But you can do some chemistry just by describing things in English. You can talk about reactions. You can talk about that sort of thing. In math, it isn't just new language. It is its own unique language. It's not just a subset of language. It has a language all its own. So, all that as a preface to this whole talk. So math is writing, math is a language, or should I say math is languages. The interesting thing is that math was developed across the world in a variety of languages. And so some parts of math actually come from Arabic roots. Algebra, right? Algorithmus is, from saying it right, is we get our word algorithm from the guy who discovered it. He was Arabic speaking. So, there are other places that we've learned things about math, but it's important to know that, first, math is not a universal language. It isn't like every kid it just wakes up at 6 months old and suddenly knows how to do math. If that were the case, people wouldn't struggle with it so much. Math's not a universal language. Every culture across the world has had their own unique way of dealing with counting and numbers and abstract concepts. There are some South American cultures that use knot systems, and so they tie strings and knots to keep record a certain way, and different knots have different counting meanings. Other symbols, like the Egyptian eye symbol, is how they built fractions. If you want to know some of the different ways cultures have used math in the past, there's a really great series called The History of Maths. I think it's on YouTube, but it used to be on Netflix. But go look at that, History of Maths. All kinds of fun stuff that is more about the writing than it is about the math. I find it really interesting. The invention of zero and that sort of thing. But suffice to say, every culture has different symbols for describing the same thing, the same numbers. Now, let's talk through this a little bit. So math is not a universal language. I don't care what the movie Contact says. Just because aliens sent us a bunch of math that we could understand doesn't mean it's a universal language that's a fictional story. There would have had to have been some sort of translation. Let's talk through this and also to think about our application of writing systems. How many different ways can you write or communicate the number 144? So we see the numbers 144 for that standard way of writing it, numerical language. We could use the alphabetic English text 144. We could use the alphabetic Spanish text 144, right? So those are three different ways using two different types of writing systems, and one of them is in two different languages. So the alphabetic system. Then we have this 12 times 12. 100 plus 40 plus 4. If you're into Common Core or you're the parent of a kid and you're like, why? There's actually a really good reason they do this. The logic behind it's sound. Sometimes the problems are worded kind of funny, but the math breaking this up into pieces is really good. What other ways could we communicate 144? 12 squared, or the square root of 20,736. Are you getting the idea? None of this would be universal, and I'm only talking about the common ways that we know of, like the now understood in Western culture ways of thinking about this one number. We have multiplication, addition, square root, exponents, English, Spanish, and if you don't know Spanish, you don't know that second one. If you don't know what multiplication is because you're 8 or 7 or 6, you might not know what the 12x12 means. If you don't know what exponents are, even if you knew what 12 times 12 was, if you've never heard about exponents or square roots, that last line won't. Then we've got 1 plus 1 plus 1 plus, all kinds of combinations if we do addition and multiplication. There's factorials and all that fun stuff. My point is to say that math's not a universal language. Even just one thing in math, one concept, one idea can be represented in a bunch of different ways. Now here's the funny thing about numbers too. They are abstract until they're tied to something concrete. 144 means absolutely nothing without a unit or a substance next to it. It is a quantity that means nothing. Is it 144 ounces? Is it 144 gallons? Is it 144 square feet? The context is going to determine why that number is meaningful. And so if you're in a math class or a science class and you're struggling, sometimes it's because you think numbers you aren't contextualizing the numbers, and so the same writing principle applies. So we've got all these different ways we could write this one number. Let me play off of writing systems and let's push this a little more. So what about the following? Okay, this is gonna be fun. You ready? Are you ready? This next thing is interesting. It's fun. It's a pictographic writing system for dealing with math. I'm also stalling because Alexa is talking in the background and I don't know if you can hear it, but here we go. This is the same. That is one way to write 144. This is one type of multiplication. I think it has roots in Japan. I don't know the full history of the model, but let's look at it. So this is supposed to be another way to communicate 144. Why? So if you look here, we have the blue dot is the hundreds place. It's all the way on that left side, or for you it might be the right if you're looking at the screen. I don't The middle column is the tens, and the far right, where the green circles are the ones. So this works with all kinds of multiplication problems as long as you know where you're supposed to break it up. So as we look at that, this is just one more way to write that one thing. So the important thing to note is math is not a universal language. There are all different ways we can communicate the same exact concept, abstract concept, in math language. All of these are legitimate forms of math language, but you have to look at the context and the type of math that you're supposed to be learning to figure out which way am I supposed to be communicating in this context. So let's break this down and talk about principles of applying writing systems, applying writing to mathematics. Here's what we have. Mathematics uses morphemes and morphology. Go back to my videos on linguistics to think this through first. Okay, morphemes. These are morphemes are the smallest unit of a language that changes meaning. They can be written or spoken, but since math is primarily written at this point, we can just look at individual letters, numbers, symbols. So x, y, 5, 9, a, b, plus equals the multiplication symbol, percentage symbol, the division line. All of those are individual morphemes that when combined in different ways change the meaning of the math language. The same way when we add different prefixes and suffixes to a word in English or Spanish or whatever, we get new meaning. We get adjusted meaning. So think about that. Apply that. So if there are morphemes, and if that means we have pieces to build words with. If there's morphology, that ology means there's a logic behind the meaning. So we want to look now, is there a logic to how we build words in math language? Each of these morphemes uses a logic to build words. So if we look at 2ax, 9y, 59%, those come together in specific ways. The percent sign is always at the end. 2ax versus 9y, there's always a sequence to these. If you said a2x, that would have a different meaning. If the 2 is at a different spot, that would have a different meaning. And so there's a pattern to how some of these units of meaning are built. And so that's that morphemes and morphology. Also, math has syntax because has its own language. It has specific sentence organization or structure. We've got y equals 2ax plus 9, f of x equals x squared plus 15. And so we have specific symbols that go in certain order that if some of those symbols are left out, that throws off the meaning. If things are put in different places, there are some instances where things can be moved around. Just like in English, sometimes you can put one word here or another word here. But in other instances, moving a word, even in English, moving a word into a different spot can change the meaning drastically. Not using a comma in a certain place could affect meaning. Let's eat, comma, grandma versus let's eat grandma. There's a difference. That's one of my favorites. Don't eat your grandmother for Thanksgiving. It's messed up. Use the comma. In this case, if we left out a plus sign or if we had put one mark and didn't do the vertical mark, just the horizontal for the plus sign, it would change it to a negative sign or a subtraction symbol. And so that would change the meaning, a single mark like that. So we want to be aware of how these things build meaning and how they can have specific structures. So math has this thing called the commutative principle, where multiplication and addition, it doesn't matter what order it's in, but subtraction and division, it does matter what order it is in. And so that it directly applies to the syntax of math, that there's a specific order. Even if you don't think about it like that, there's a specific order for dealing with a math sentence. And so some people do it as PEMDAS, but if you're going to do that, you want to kind of, it's actually 4, not 6, and you want to group those differently. Ask your math teacher in college; they will tell you why they don't like PEMDAS generally. Anyways, please excuse my dear Aunt Sally. Anyways, as we push forward, if math has syntax and math has morphology, just like with other languages, math can have fragment sentences and run-ons that cause miscommunication. So if someone says, what is 4 times 4? You might go 4 plus 4 equals 8, plus 4 equals 12, plus 4 equals 16. And the logic in your mind makes sense. You're adding and building each time. But when a math teacher looks at this or a mathematician looks at this, they see this error. 4 plus 4 doesn't equal 16. And so you want to make clear each step, because otherwise that 4 plus 4 equals 8 plus 4 equals 12 plus 4 equals 16 in that second bullet point, this is a math equivalent of a run-on. You have too many pieces built together and they miscommunicate. So because there are norms, practices, and expectations to writing in mathematics. A fragment sentence, in contrast, is if I say 4 times 4, if I didn't have the what is, if I just put 4 times 4, math wants a sense of completion. If I put 4 times 4 equals, there's an even bigger need. It's like you're supposed to know what that equals. So a complete sentence in math, instead of a fragment or a partial sentence, is 4 times 4 equals 16. So we have run-ons and fragments. Those syntactic principles still apply, and because there are social norms, practices, expectations to how this unique language is supposed to be communicated. Math. Okay, continuing on. So beyond linguistics, math language is rhetorical and sociocultural. Math language has common structures, forms, and patterns of communication. We've talked about that before when we talked about genre. There are genres that are common or generic structures that mathematicians will use to solve certain problems. So the audience has certain expectations that are based on the culture of math and the rhetorical context, and math uses specific genres. So for instance, if we're, that's supposed to be an equal sign, y equals mx plus b is a traditional generic form of what? If in junior high, you might have heard this, it's the generic form of a linear function, y equals mx plus b. Now, when you get to college or college level algebra, they'll get grumpy about this because there are a lot more components in here. They'll say instead of y, it'll be f of x, and instead of m, it'll have some other things. And so there's a little more to this. But we have these generic forms, a equals pi r squared for the area of a circle, c equals 2 pi r, area of circumference. And I'm keeping math simple here and not getting into the common structure for limits or the common structure for integrals or derivatives and that sort of thing. These are, but the generic form of a math equation like this is a genre. Now, just like a genre in English writing, where we look at the big picture structure, say traditional essay, intro, body, conclusion, or traditional lab report, IMRD, there's a specific order, but when you actually go to write it, it shifts from a genre generic structure to an actual text with unique content specific to the lab or the experiment you're performing. The same thing is true with these. When you drop in y equals mx plus b into a specific situation for a word problem or something like that, if there are specific values, now it becomes anchored to its context. It's no longer the genre or the generic form, it's now an individual text that you have to work through. So instead of y equals mx plus b, it's going to be y equals 4x plus 7, which will give you a pictographic form, which gives you something you can graph in pictographic form. You can draw out the line crossing the x or crossing the vertical axis at 7, and that sort of thing. Yeah, so fun times with a slope of whatever number I set. So we want to think about math as a language. It has morphology, it has morphemes, it has syntax. It is rhetorical and sociocultural as a language. It has unique genres, so we can think about that when we are thinking about math as writing. These are generic structures for math communication, and they've not, because they haven't been applied to specific contexts, they're not texts yet until you tie them to a specific experiment or a specific word problem or a specific train traveling at 80 miles per hour in one direction and that kind of thing. So with that is math as a language. There are plenty of other things we could say about this. Depending on your level of math, these principles may be easier to apply or harder to apply. I haven't even gotten into why it's so cool to think about math as a language that can cross multiple systems, and so maybe I'll go into more depth in another video. But just as a kind of a cliff or a nugget, you can write math in the way we've shown here. And this can sometimes confuse people, but if you understand it, you get it. But the cool thing about representing math in this way or using some of those functions is that oftentimes we can use these numbers and symbols to build a data set, and then we can use that to start visualizing a real life situation. And as those numbers change, the graph changes, and we can start telling the story behind the math. So I might zoom in on some examples that I know from the MAT 151 or 187 curriculum at some point as a further application of this, and just because I geek out about it. But this has been math, the application of writing to math, math as a language, math with its various writing systems. So apply it, let it help you better process some of the information you get from that other course, those other mathematics courses you're in. And if you struggle with math, remember math is a language. So you have to learn the language and learn how the words fit together and learn the common forms of writing. So because math is writing and math is a language, don't feel bad if you don't get it right away. Just like you shouldn't be mad at people if they're struggling to conjugate English verbs and they've only been speaking it for 6 months. Instead of saying I am, they might say I are. You're not going to get mad at them for that. Don't get mad at yourself for that. Because the essence is there. But you have to learn how to see math this way to continue to grow and understand how the pieces work together. If you don't know the basic definitions of some of the things you're dealing with, what's a function, what's a linear function, what's a quadratic function, what's the unit circle, what's a limit, what's an asymptote, those things are important. You have to get those things down before you can start manipulating the numbers and the functions and the equations and things like that. So have fun. This is an application of writing to math.